Okay, guys, I hope you had a really good snow day. And I'm sorry if you didn't. Folks, the do now, which thank you, Marcus, thank you, Nora, thank you, Ariana. The do now is to correct your homework with the rating guide that is on your desk. So please notice that I would like you to not use a pencil to do this. I would like you to use one of the colored pencils at your desk. So that's what I can tell. I can tell the difference between what you corrected versus what you originally did. So if you're looking at the rating guide, you'll see that I crossed out question 43. Question 43, I didn't even understand it when I looked at the rating guide. So do not grade question 43. It was not a very good question. Just grade 39 through 42. Okay?
I didn't get my homework because I didn't need a lab, so I just put it back.
Okay, go get it. All right. You okay, Christian?
I didn't get my homework. It's in my math binder.
Quick.
I put it in my math binder.
Oh my goodness gracious.
What? Wait, it's on because I put it
Okay, go get it. Okay. You don't have to tell me why. Go get it. Did you correct it? Oh, I see what you mean. Guys, you have 3 minutes to correct your homework, okay? I'm going to put a timer up on the board. Okay, you found yours? Okay, good. Can't see the timer. Mm-hmm. Oh, so it's 17 plus or minus 1. So 16 would be okay. Okay. I know. I was just about to come out and tell you. Where's yours?
Thanks.
Okay. You may go. You're the last person to go. All right, listen up. Guys, a lot of people are going out to get their homework. Let's come prepared to class. So once again, you're correcting with the colored pencils that are on your desk. Okay? So no, at this point, no one else is going out. Okay? You're just going to take the zero handed in later. Question 40. Please look at the reading guide for question 40. If you wrote, Christian, if you wrote 16, 17, or 18 for question 40, that would be correct, okay? It says 17 plus or minus 1. Okay, once again, we're not grading question 43. No, it means that they would accept any answer that would 17 plus or minus 1. So you would be correct if you wrote 16, 17, or 18. Any of those numbers would be correct for that question, okay? 16, 17, or 18. All right, did you write 17? Yeah. Okay, then you would be correct for that. Okay, so you could just write a check. Okay, so if you're done with your correcting your homework, could you stack the reading guides and the homework in 2 separate piles, please? And could one person from the table get the rest of your groupies an iPad? Okay.
I'll do it.
Okay, guys, the period 1 code is on the board. Let's see. Dean, can you log into Notebook, please?
And the fact that I rode your bus and I didn't notice the similarity.
Are we doing your bus?
Guys, the code for period 1 is on the board, TSWBF. There's a period 1 code and a period 2 code, Marcus, right? Caden. Did you already sign into the Nearpod, Caden? Okay. Guys, please sign into Nearpod. Thank you, Ariana. Christian. Rice. Ravina.
I got 10 out of 10.
Okay. So guys, what I just handed back is the open notebook quiz that you took on, what day was that? Tuesday? So I wrote your grade in purple on the top, so that would be your grade. Don't worry about the percentages that are printed. So we're just going to go over some answers that were commonly missed. So that would be slide 9 on that first page. A lot of people got wrong. What's another one? A lot of people got partial credit for slide 7. You'll see on the second page, how do machines make work easier? So if I wrote PC, that means partial credit. And then a lot of people, a mechanical advantage is something that we also need to review. So that would have been slide 10. Okay, so we're just going to do a quick review of some commonly missed questions. Yes, Marcus? That would be, I don't really understand, honestly, how Nearpod grades it. So I just wrote your grade on top in purple. Okay. Compared to everybody else. Okay, so guys, yeah, what's up, please? Okay. Guys, take a look at your screen, please. So everyone should be logged into Nearpod at this point. Okay. Take a look at your screen, please. Alex? Oh, really? All right, so work in equals work out. So this, slide 9, machines make work easier by reducing the amount of work you have to do. A lot of people said true, because that seems intuitive, that machines reduce the amount of work you have to do, but they actually don't. So on the screen it says machines do not change the amount of work you have to do. They simply allow you to complete work with less input force or effort. Okay, so this is a very common misconception that machines change the amount of work you have to do. They don't. They change the amount of force it takes to do work. So there's a quiz on your screen. Which is more work? Lifting a box 3 feet off the ground, pushing that same box to the same point using a ramp. So a ramp is a simple machine. Or neither, the amount of work done is the same in both scenarios. What do you think? Which is more work? Okay, if you haven't submitted yet, please get your submissions in. Bryce, did you submit? Yeah. Oh, okay. So there's a little bit of a lag. Okay, so let's see the results here. So a lot of people said A, a lot of people said C. C would be the correct answer here, okay? So as I said before, machines don't reduce the amount of work you have to do. So the amount of work done in both scenarios was the same, and let's review how that's possible. Because it just doesn't seem like that is right, even though it is. So take a look at, what's his name again? Moby? So Moby, in this scenario, he lifted a box from the ground and then he jumped to the top of this platform. Okay, he wanted to move the box to the top of the platform, so he jumped to get it there, right? So look at the work equals force times distance equation. Okay, I capitalized force because he had to apply a lot of force, right, to jump with that box onto the platform. That took a lot of force. Okay, distance is lowercase because the distance he went is pretty short, right? It's a pretty small distance. Do you agree? So he exerted a lot of force over a small distance. Yeah, Chase?
Well, they had to jump question about it, but I know how like in math, if we put a capital, like y equals x, whatever in like math, if
Yeah.
we put a capital, it messes everything up. Is that
So the only reason I made it capital here is because I couldn't make the font bigger. I just wanted to show you that the force is really big here and the distance is small. Does that make sense?
Yeah.
Okay. In this case, no, but in math, if Mr. Tanja says it does, then it does. Okay. All right, so, or another way that Moby could have gotten this box to the top of the ramp is he could have walked a longer distance, okay, using less force. So this simple machine didn't change the amount of work Moby had to do. It just meant he could use less force to push the box a longer distance. So the trade-off is he gets to use less force, but he has to move a longer distance. Does that make sense? But the amount of work is the same. The ramp didn't cut down on the amount of work he had to do, right? It just meant he had to use less effort over a longer distance. Does anyone have a question about that? Okay, we'll move on to the next review here. How do machines make work easier? So a lot of people just said one thing or the other, and I gave you partial credit if you said one or the other, but I was looking for both in your notes. Most machines make work easier by either amplifying your input force or changing the direction of your input force. What does amplifying mean? Someone want to raise your hand? What does amplifying mean? Cody? Making it bigger. So a machine will either take a small force that you put in and turn it into a bigger force, or change the direction of your input force. And I think I have like a little quiz for that. Let's see. Okay, so this bottle opener is a type of simple machine. It's a lever. So the question is, does a bottle opener change the size or direction of your input force? Do you want me to go back to the image of it? Okay, I'll just go back to the image of it for a minute. Does a bottle opener change the size or the direction of your input force? I'm going to freeze the screen. Or both. Or both. Okay, so most people said both. Most people said both. Oh, do you want me to? It changed? Let me see. I thought I gave everybody enough time. Okay, so if you didn't answer, either go with the masses or go your own way. Okay. Okay, has everyone answered now? Oh, guys, come on here. All right, there we go. Okay, so you pull up on the bottle opener. There's a little tab here beneath the cap, okay? So you apply an upward force on the bar, right? You're pulling up on the bar. Is everyone with me there? Okay. So the little tab also pulls up on the cap. So is the direction of the force changing? No. It seems like that because this pushes down, but this part is not the part that is taking the cap off. It's this tab. So the direction of the force doesn't actually change. Okay? As Ariana just said, the size does. Okay, think about the force that could you just take that cap off with your fingers? No, but you can with a bottle opener. Okay, it changes the size of your force. So it takes a relatively small force that you pull up with, and it amplifies it so that you can take the cap off. Okay, so it changes the size of your input force. You wouldn't be able to do that without that simple machine. All right, last review question. Mechanical advantage is how much a machine multiplies the effort force put into it. Okay, and the equation is output force divided by input force. So mechanical advantage means how much does that machine amplify or increase your force. So you apply a force of 10 newtons to a bottle opener, and the output force is 30 newtons. What is the mechanical advantage of the bottle opener? Okay. Mechanical advantage, I'll write the equation on the board again, equals output force divided by input force. Correct, Marcus. Good remembering. There's actually no unit for mechanical advantage because newtons cancels out. So it just leaves a number by itself. Yep, great. Did you say 20? What did you? No.
I put 3.
You put 3?
No.
Okay. I thought, are you? Oh, you're the potato. I thought you were eternal gamer. Okay. Okay, have we gotten most people to submit here? Correct. If you're just waiting, after this, there's going to be a lot of papers and glue and scissors flying around. So can you clear your desk of everything but your iPad and your ISN? Not literally flying. That would be really cool. But. Oh, thanks for, leave that, leave your homeworks out too. Thanks, Marcus. Pretty cool. Okay. So let's take a look at what you guys said for mechanical advantage.
Wait, look at mine.
It has confetti. Aww, that is really cool, Dean. Mariah did 30. Mariah did 30 divided by 10. She got 3. That would be correct. That was the mechanical advantage of the bottle opener. It looks like most people got that. Okay? Most. Output was 30. Input was 10. It's okay. So Chase, the output was bigger than the input, right? So the bigger number would go on top. Okay. For that one? Okay. Okay. So what we're going to do now is we're actually going to be switching to a different Nearpod presentation. So I'm going to put the new code on the board for the notes that we're going to take. Okay. So please exit that one. Yeah, exit that Nearpod presentation because we're going to actually be doing a new one, and this is the code for the new one. Faith, put in the new code, okay? Thank you, Ariana. Thank you. Did you put in a new code, Chase? I did. Thank you. Thanks, Sabina. You got my back. We're having it next Monday. Okay. Monday, Wednesday. I know. Put your name. I got you back. It's okay. Okay, so everyone should be at a slide that said simple machines, right? Yeah. Okay, so what I want you to do is open up to a fresh page in your ISN, and in the space above the lines, like that big white space at the top of your paper, did I drop it again? I want you to write simple machines and the definition. So in the white space above the lines, does that make sense? Kind of what I'm saying? Okay, I want you to write simple machines and the definition. Okay? Fresh page in your ISN. So in this area right here, I want you to write simple machines and the definition on the page. Okay? Azzy, where's your ISN? Okay, remember what I said? How you need to be on time and prepared?
I was prepared. I had my stuff.
You didn't have your ISN. Okay, go get it because we're going to be using it a lot. Okay. Okay, and while you guys are doing that, I'm going to be passing around a sheet for you to you can okay, do you want to I'll do that side of the room, you do this side of the room, everyone needs one of these. Okay, awesome, thank you. Can one person from the table please get glue and scissors for your table mates? There you go.
He used that.
You got them, Marcus? Thank you.
Back up and there was like,
Thank you so much. Okay. I got it. No worries. Thanks, Marcus. What? Okay, guys, so let me explain how this is going to go into your ISN. Listen up. The first thing you are going to do is, eyes up here. Eyes up here, Dean. The first thing you are going to do is fold it like this. Okay, and it kind of goes along my solid lines that I made on the inside. I'm going to fold it like this. So, yeah, it's like the vocab foldable. Okay, so you want your sheet to look like this? Okay, what you can do next is, if you go along my dotted lines, you'll be a little bit off. They don't match up perfectly, but you want to cut so that you can open up each of these separately, and I'll show you mine as an example. So, like this. Okay? Dean, you doing this? Huh? Okay, you don't need scissors to fold. Okay. So this is the first thing that you're doing, Dean, is folding it like this. Okay. Great. And then you want to cut them so it's like that. Yep, Sam, I'll take that. You can get it at the end of the period. Okay. Thank you. Okay. So you're going to cut like that? Okay. Cody, it should be like this. So, let me see. I'm going to give you a new one. Can you look at how Ariana did it? So fold it in like that. Okay, looking good. So the next thing you're going to do, you are going to flip your sheet around to the blank side, put a dot of glue in each corner, and paste it down into your ISN. Okay? So on the back side, put a dot of glue in each corner, paste it down into your ISN. Yep, just a dot.
Hard. How it is.
Okay, that's enough.
Yeah, but it's broken.
Does not not working for you? Is there another table that would like more glue? No? Okay. So for people who are all ready, I'm going to go to the next slide so you can start with the notes. So the first one we're doing is lever. So it's fill in the blank. Okay? It's fill in the blank. The first one we're doing is lever. Did you get the lever thing down? Okay. Yep. So we actually have to take more extensive notes for lever than we do for the other 6 simple machines that we will be learning about. So there's another thing coming around to paste on the next page of your ISN just about levers. Here's this.
Okay, so for table of contents,
Yes.
put a new one.
Yes. You'll put a new line for your table of contents. Okay. Okay, the sheet that is coming around is just about levers. We have to take more extensive notes on levers than our other 5 simple machines.
We're here to go by tonight.
Last night did you go by?
No,
No. I'll hear you come by
Yeah.
tonight. Awesome. Makes me smile, Caden. Sitting on my couch, I'm like, there he goes. Okay, please put that sheet in the next page of your ISN, the sheet about levers that I just passed around. This is going in next. Chase, okay. Yeah, so in your table of contents, Marcus is asking, so the simple machines foldable, you can call simple machines foldable, okay. And the levers sheet, you could call levers in your table of contents. So there's a simple machines foldable. That's the first thing we put in, simple machines foldable. And then the sheet I just passed out, the title is levers. Okay? Today's date is 2/8/18. Okay? 2/8/18. So in your notes that's just about levers, if you're ready, you can start filling in those blanks. There's 4 parts. And what you need to do is write the definition next to the 4 parts. Okay? Did you put the levers page in, Lizzie? You put the levers page in? This needs to go in next. Yep. So take a look at your screen if you're all ready, and you can start filling in the notes for the 4 parts of a lever. Okay, you can get it down. Yes. Oh, you can get that definition down. I can give it to you during the academic file. Okay. But there's a new note that you can take, Christian. Okay. So it should switch to the next slide here. Okay. So did you put the levers sheet in? This needs to go in here. Okay.
What's the definition for a simple machine?
Can you go to me 8th period and I'll give that to you? Okay. So do you have your levers sheet in? Okay, so we're filling in the definitions of the 4 parts. Okay, we're filling in the definitions of the 4 parts of a lever. Yep, 4 parts of a lever. Christian, you're going to have to get a move on here, okay? So as you were filling in the definitions of the 4 parts of a lever. Okay. Cody. You're going to paste in that, okay? And we're going to move on, so you should come to me 8th period to get the notes that you missed while you were in the bathroom, okay?
Okay.
Okay, it looks like most people have the notes down, so I'm going to go to the next. Okay, so I will go over this slide while people are getting the last words down. So there's 4 parts to a lever. Okay, there's the lever arm, which is this plank, okay? The fulcrum is the point where the plank pivots or turns. Have you guys heard the word pivot before? Yeah? Okay, so pivot, someone want to put pivot in their own words, even though I just kind of did? Dean, what's pivot mean? Rotating, it's where the lever rotates or turns. Okay, there's the load, okay? The load is the thing you're trying to move or lift, okay? So if you think like a seesaw, the load would be like the other person, okay? And the effort is the force applied to move the load. So again, if you're thinking of a seesaw, the effort would be like you, okay? So 4 parts of a lever. Effort is the force applied to move the load. Okay? So there are 3 types of levers. There's a class 1 lever, class 2 lever, and a class 3 lever. Okay. Class 1 lever, so you're going to fill in the, let me see what you have to do here. You're going to fill in the blanks here and then label on the line the location of the fulcrum, the effort, and the load. So first you're going to fill in the blanks. Some people got to it, others didn't, because you guys did them in all different orders. A first class lever has the fulcrum placed between the load and the effort, so you'll fill in the word fulcrum. Okay, and then on your line, I'll show you what you're going to do. Okay, you all have a line underneath first class lever. So you'll draw the fulcrum as a triangle, and you'll label it fulcrum. Okay, you'll draw the load as like a square or box. That's going to represent the load. Okay, and then the effort will just represent with an arrow. Yeah. Nope, it doesn't matter which side the load and the effort is on. Okay, so if you have it swapped in yours, that's fine. Okay. Okay, we ready for the next slide? All right. So here actually I have an example of a first class lever. So one example would be pliers. Okay, the fulcrum is between the effort and the load. Okay, so what you're trying to move might be, you might be trying to cut a wire, right? Or you might be trying to pull out a nail or something, and you're applying effort to the handles. Okay, so pliers are actually an example of a first class lever. A hammer pulling out a nail is also an example of a first class lever. So label the fulcrum, the effort, and the load on the hammer. Okay, so think about, where does the hammer pivot? Where's the pivot point? Okay, then what is the thing you're trying to move? That would be the load. And where are you applying effort or force? That would be the effort. Where is the hammer pivoting? Label that the fulcrum, or F. Okay, if you use abbreviations here, that's totally fine. Your thing is not working, Beth? You did? Okay. Looks like a shrimp. Okay, I think most people are done. So So I'm going to share Wyatt's, although many of you have something similar. So the fulcrum this is where the hammer is pivoting, right? This is the pivot point. So Wyatt labeled that the fulcrum. Okay, the load is the nail. That's what we're trying to move. And you're applying effort to the handle, so that would be the effort. So this is a first-class lever. The fulcrum is between the effort and the load. So a hammer would be another example. Okay, good job, guys. Let's see. Class 2 levers. So again, you're going to fill in the blanks here. And you're going to label the fulcrum, the effort, and the load. So a class 2 lever, the load is between the effort and the fulcrum. So now the fulcrum is at one end, effort is at the other, and the load is in between. And again, you're going to label using the same symbols that we used before. You're going to label the fulcrum, the effort, and the load. So Azzy, you're not quite done, right? So on that line, again, you're going to label the fulcrum, okay, the effort, and the load. Please don't just use symbols, also label with words, okay? Sam, you having trouble logging in?
No, I accidentally logged out and the code's not there anymore.
Okay, I'll try to get the code for you. Okay. Sam, the code is VFU VFUXD. Okay, next slide. Are you guys writing examples down? I forgot to mention that. It says examples underneath. Okay, so examples for a first class lever. What was one example? Someone raise your hand. Okay, Marcus said pliers. Someone else raise your hand. What's another example? Christian. A hammer. So under first class, and also seesaw. So under first class lever, you could write hammer, pliers, seesaw. Those were 3 examples for a first class lever. And on your screen, there are 2 examples of a second class lever. So I'll give you a moment to get the examples down. You don't see them on your screen?
No, I do not.
Okay. So make sure you get examples of a first class and second class lever down in your notes, okay? All right, I'm going to move on to the next slide here. Okay, here is an example actually of a second class lever. Okay, so the fulcrum or the place where the bottle opener is pivoting is here, right? That's the pivot point. The load or the thing you're trying to move is here. And the effort you're applying is here. So a bottle opener would be an example of a second class lever. The load is between the fulcrum and the effort. Okay. And here is that. So the load is sometimes called the resistance. That's why it's labeled R on the screen. Okay. All right, so now with this wheelbarrow, please label the fulcrum, the load, and the effort. Oh, you can't. I'll switch it to the next slide. There you go. Now you can. Excuse me. Mark, can you pass me your scissors? Okay. Let's see. What do we got? Okay, so I'm going to share Bryce's. Okay, so Bryce labeled it correctly. The fulcrum, or the place where the lever, right, is pivoting, would be here, sort of in the center of the wheel. Think about using a wheelbarrow. That's where it pivots. Okay, the load is, the stuff in your wheelbarrow. And the effort you're applying is to the handles. So this is an example of a second-class lever, and it's correctly labeled. Okay. So we actually have to clean up now. So this is how it's going to go. So please make sure that you exit Nearpod and then click the 2 squares at the top of the screen and X out of the tab. One person from each table, please return the iPads. Okay, could one other person at the table please return the scissors and the glue? And I'm going to hand out an exit ticket, okay? The exit ticket is, please try to look around the classroom and see if you can find any levers. Okay, what you're going to write down on your sheet is, what levers do you see in the classroom? Okay, I'm handing out an index card. Please write your name on it. What levers do you see in the classroom? What levers do you see in the classroom? Please write it on your index card along with your name. These are I'm reusing these. So you just happen to coincidentally get your own. Okay. I'm going to say it again, okay? So guys, quiet while I explain what the exit ticket is, please. Shh. So on your index card, you're going to write your name. And then you're going to write, what levers do you see in the classroom? So we've only gone over type 1, class 1, and class 2 levers. But there's quite a few class 1 and class 2 levers in the classroom, actually. So look around the room and try to think of any examples you see in the room of first or second class levers. Okay? That's your exit ticket. You are going to give it to me on your way out the door today. Okay? So write down as many as you can think of, as you can see. So guys, points today are for chairs pushed in and iPads put away correctly, okay? Please hand me your exit ticket on the way out the door and have a great day.